Good morning, students of class 12. Well, today I'm going to teach you Kirchoff's laws, and the name of the chapter is electric measurements. So actually there are two laws given by Kirchoff. There is first law, there is second law. If you want, you can write it down. It is better if you write it down. Okay, students, now you have to draw this figure. Well, this is Kirchoff's second law, you can see. And so Kirchoff's second law states that the algebraic sum of the products of the currents and resistances of any closed part or loop of an electrical circuit is equal to the algebraic sum of the EMFs acting in that part or loop of the circuit, that is, summation I R is equal to summation E. Well, I stands for current, R stands for resistance, E stands for EMF. And you have to draw this figure. Alright students, I have written an alternative form of Kirchoff's second law. Please copy this down. The law is also stated as the algebraic sum of the changes in potential around any closed circuit involving resistors and cells in the loop is 0. That is summation V equal to 0. The EMF of a cell. Now students, I would like to tell you some relevant features regarding Kirchoff's second law. For applying this rule, following sign conventions are adopted. The first rule is the EMF of the cell is taken as negative if one moves in the direction from negative terminal to positive terminal through the cell, and is taken as positive if one moves from positive to negative terminal through the cell. Please copy this down. Alright students, I think I have forgotten to explain the Kirchoff's first law. Actually, Kirchoff's first law states the algebraic sum of the currents meeting at a junction in a closed circuit is 0. I hope you have written down the statement. That is, summation I is equal to 0. Now, let us consider a junction O in an electrical circuit. I have drawn the figure on the left hand side, which I had drawn previously also, but I think I forgot to explain. So now I am doing the explanation part. So please listen to it carefully. You have to see the junction O. Let us consider the junction O in an electrical circuit, which I have drawn on the left hand side, at which currents I1, I2, I3, I4 and I5 are flowing through 5 different branches of a closed circuit. Now consider the following sign convention. The current flowing in conductor towards junction is taken as positive, and the current flowing away from the junction is taken as negative. So students, if you see the figure carefully, you will see that I1 and I3, these two currents are entering the circuit. Yes, see the direction of the arrow, I1 and I3, they are entering the circuit and meeting at the junction O, whereas I2, I4 and I5 are leaving the circuit. That is, I2, I4 and I5 are moving away from the circuit. I2, I4 and I5 are moving away from the junction O, that is, they are leaving the circuit. So according to the sign convention, I2, I4 and I5 are taken as negative, and I1 and I3 will be taken as positive because they are entering the circuit, that is, they are meeting at the junction O. So according to Kirchoff's first law, I1 plus I3 minus I2 minus I4 minus I5 equal to 0, or I1 plus I3 equal to I2 plus I4 plus I5. That is, total current flowing towards the junction is equal to total current flowing out of the junction. Thus, Kirchoff's first law is based on the law of conservation of charge. Alright students, I think I was actually explaining the sign convention while applying Kirchoff's second law. So I have already explained the first rule of applying sign convention regarding Kirchoff's second law. Now I will explain to you the second rule regarding Kirchoff's second law. So you have to write it down. The product of resistance and current in an arm of the circuit is taken positive if the direction of the current in that arm is in the same sense as one moves in a closed path, and is taken negative if the direction of current in that arm is opposite to the sense as one moves in a closed path. Alright students, now I am going to explain to you Kirchoff's second law. Please follow me. Moving across the circuit A, B, C, D, A. A, B, C, D, A. A, B, C, D, A. Now, when I am moving across the circuit A, B, C, D, A, that means I am moving in the direction of the current. See the direction of the current. See the direction of the current. So actually, when I am moving across A, B, C, D, A, I am moving in the direction of the current. So according to the sign convention, it will be minus I1 minus I1. What is the resistance? R1. Minus I1 into R1, and I am moving from negative to positive. So plus E1. Now I am moving in this direction. A, B, C, D, A. I am moving in this direction. Again I am moving in the direction of the current. So again minus I1 R2 will be equal to 0, or I1 R1 plus I2 R2 is equal to E1. Understood? Now, moving across circuit A, B, F, E, A. A, B, F, E, A. So again minus I1 R1 minus I1 R1, I1 into R1. I am moving from negative to positive, so it will be E1 will be positive. Now I am moving like this, A, B, F, E, A. That means now I am moving against the direction of the current. See the direction of the arrow. So it will be positive plus I2 R3. I'm moving from positive to negative, so E2 will be negative. Or I1 R1 minus I2 R3 equal to E1 minus E2. So when you are moving in the direction of the current, I repeat once again, when you are moving in the direction of the current, the product of the current and the resistance in that particular arm will be taken as negative. So when I was moving from A to B, actually I was moving in the direction of the current. So it will be minus I1 into R1. Product of the current and the resistance will be taken as negative if you are moving in the direction of the current. And about the EMF, when you are moving from the negative to the positive terminal, E1 will be positive. So E1 was positive and I1 R1 was negative. When I am moving across A, B, F, E, A, that means when I am moving across F, E, I am actually moving against the direction of the current. So according to the sign convention, the product of the current and the resistance will be taken as positive, because I am moving against the direction of the current. See the direction of the current. So I2 into R3 will be taken as positive. Okay? And moving from positive to negative, so E2 will be taken as negative. E2 is taken as negative.